Okay. All right. Looks like we're ready to go. So let's go ahead and get started. Everyone, good to see you virtually. Thank you for joining us. This is going to be the last lecture that we do online. So next week, we have fall study break on Monday, and we have a film on Wednesday. The week after that, we're going to be back in the Biz Studio for normal lectures. And if you look at where we are right in the middle of P2 milestone. So if you haven't begun on that, you're going to want to get started. Remember, in the last recording, we did a ton of the tasks that you're going to need for this upcoming deliverable. And we're going to do a few more today. Hopefully it won't be too bad. And hopefully you'll be able to take that fall study break off and kind of recoup, right? Get your energy back, get your morale back, get your other courses on schedule, and yeah, it should be a good time. So, a quick reminder, your P2 milestone will be due not at the normal time on Monday at 1:30 p.m. EST, but it will actually be due on Sunday at 11:59 p.m. EST. So please do not forget, otherwise you will end up with a late penalty, which is never good. So, let's go ahead and take a look at a company, okay? Your XR company of the day. This is a local company. This is Pixo VR. They're based in Royal Oak. They are funded, I think, at least $4.5 million. So they've got quite oh, yeah. You know what? I think they now block the total amount. They hide it behind something. I remember going to visit them a few years ago, speaking to Sean, a very cool person. They are a company that builds training. They use VR to build training environments, training simulations, challenges that can be automated. They can have random elements in them. They are multiplayer, which is super cool. And you can just see right away from their website, right? This is about mechanical training, safety training, warehouse training, first responder training. They work with a lot of different companies, apparently. Ford, no surprise there, very close. Consumer Energy, local company. Even doing things with California, Water Service, General Dynamics. So pretty cool stuff. They've been around for a long time. And if they were pitching you on why you should consider using VR for your training needs, right? 4 times faster, 2.75 times more confident. I'm not exactly sure what confidence means here or how that is judged or tracked. I would like to see some methodology offered or a research paper so people can look a bit deeper if they're really curious. More cost-effective, right? More focused, more connected. You've got various tools that allow you to kind of build your own content and customize things, manage permissions and who gets access to what. You can deploy your own content, apparently, pretty cool. So create your own stuff, manage, deploy that stuff, track performance, integrate. They've got APIs you can use. Yeah, so pretty cool stuff. And it looks like they have a tool that allows you to build these experiences and training modules without needing to do a bunch of coding, which is a recurring theme. Anyway, right, workplace safety, soft skills, labor, public safety, industry-specific training, blah, 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 blah. Oh, cool, right? So they've got stuff for first responders, first aid, CPR, fire suppression. That is super cool. They've got manufacturing, hazard recognition in a warehouse, electrical safety. This is really cool. Forklift simulator. Okay. I want to see that. Active listening. Okay. They've got a video.
Each time before a forklift is used, a pre-operational inspection must be conducted.
The forklift controls, from what I can see, look very fairly simple. I've been in machines that have a very, very complex interfaces, and memorizing all the controls in front of you, what all the gauges mean, and when they need to be used, can be very difficult to do just from video or from textbook pages. In many cases, getting that muscle memory, right, is really important. Going through the motions, doing, interacting with all the controls can really help with retention, it seems. So it seems like a really, really cool thing. The headsets, right? You can use a bunch of different headsets: Quest 2 and Pro, Pico Neo, Lenovo. So really cool stuff. They have a lot of content. They have a tool for helping you build content, it seems. And it also seems you can pay them. A cool basketball arena. It seems you can pay them to have them build content as well. So a very, very cool, platform. I think maybe there's one more video that I'll show you, and then we'll move on. Maybe I'll show it to you if it will spawn in. Okay, what makes it different? Oh, maybe this is not a video. Okay. All right, you got it. You got it though. It is another tool that helps you kind of easily create digital content. It is very kind of geared for and optimized for first responder and kind of nitty gritty, warehouse training, manufacturing training, facilities training, equipment training. So very impressive stuff. Very cool company. I'm not entirely sure how they make their money beyond you commissioning them for certain types of content, off-the-shelf content. Yeah, so it seems they've got some stuff that you can just kind of grab from their content bank. It doesn't seem we're able to see pricing, which is always a little bit spooky. You don't see pricing, it means maybe you cannot afford it. But basically, you need to contact them. My organization is, how big you are could affect what kind of pricing you get and how quickly they respond to you, right? If you're a big, lucrative company, you'll probably get a lot of attention. Pretty cool. Okay. So, very, very cool little announcement, some very cool footage. Thanks to Emerson Hutter for sending this. An experiment, a pretty wild experiment, to inject humans into Minecraft. And I'm not talking via some sort of avatar that represents us. I'm talking, let's get video footage from many different angles of a human being. And as they walk around, let's have that footage be beamed into Minecraft.
That's just visual. We have them in Minecraft, but you can't actually do anything. In order for them to interact with the world, we needed to know where their hands and their feet were, so using AI technology, 4090 GPUs, and lots of code, boom, we have skeletons. Now we have the hands, the feet, the head, etc., full body tracking without them wearing anything. They still don't do anything, but we know where they are. And I wanted to be able to be Steve, and Steve doesn't have a controller, just his hands. So because we have their body parts location, and we also know exactly how much time is taken between photos, we have the distance their hand moved and the amount of time it took them to move that distance. So we can do this cool little graphic where we're displaying the exact meters per second of my hands moving, which just on its own is flipping awesome. That means we can now detect when you want to punch or kick without any buttons, because if it's over a certain speed, we have it do damage, and if it's not, then it does nothing. They're a massive rig on omnidirectional wheels that carries the cameras, the PCs, batteries, lights, and a very creative system to track the rotation of the rig and keep track of the movement of the person that's inside. That way, we can always display them in game, have the cameras automatically follow them wherever they walk or run, and allow them to move with no controller, just by walking. Now, you do have limited space, technically, even though we slapped the rig in a massive basketball court.
But when you reach a wall, you commit to spin.
So super impressive stuff. This was all done without mods, which is something I'm not entirely sure how they managed to do that. It certainly seems like this kind of feature is so wild that it would require at least some sort of custom logic or custom modding support. So I'll have to look a bit deeper. I did not watch all the video, but extremely cool technology. And yeah, this is making that reality a bit more real. The footage itself, when it's not moving, it doesn't look quite as good. It's very choppy, but you have to imagine with maybe improved cameras or with maybe it's a limitation within Minecraft itself. But yeah, this kind of stuff will keep looking better and better, and could be really interesting. Okay, very cool. Unfortunately, some less cool news. Microsoft is shuttering their mixed reality platform. If you've ever seen me type this, or if you've ever seen this mixed reality portal, maybe you maybe you've been using it because you got the checked out Acer headsets from the course. This piece of software is meant to allow a bunch of different brands of VR headset from many different manufacturers, Lenovo, Acer, to interact, using the same chunk of software. This is being deprecated, and HoloLens 2 has also been discontinued officially by Microsoft, and the software is going to be removed very soon from Windows 11. So I've actually turned off my Windows updates. I'm not sure if that's a good decision for security, but that should allow us to continue using the headsets for demoing examples and stuff for a few more years. This is the kind of thing that happens, and it's always really sad when a bunch of very cool and still functioning hardware loses its software support and risks becoming obsolete. The good news is that in many cases when something as disruptive as this happens, some sort of open source solution tends to come along not long after. There's a huge incentive to get those headsets and that hardware working again, and often that is possible if you want to jump through a few hoops. It's sad though. The rationale that I read was that Microsoft is abandoning their own mixed reality platform and HoloLens, but they are partnering up and preparing to integrate more closely with the Meta Quest series line. So a partnership between Microsoft and Meta, and it was stated that this was in direct response to the tight integration between the Apple's operating systems, right, Mac OS, and their Vision Pro headsets. So in that sense, it definitely does make some sense that they would do this. Anyway, let's go ahead and keep going. If you do have an Acer headset checked out from this course and you want to guarantee you can continue using it, you might want to pause Windows updates until the rest of the semester. I'm not recommending that because it's not really a secure thing to do, but you do what you want to do. Vision Pro, as we were just speaking about it, is a very impressive piece of hardware. In particular, it is remarkably good at detecting edges and walls and surfaces. And we're going to talk a little bit more about that and how it's done in a couple lectures. But I saw this app. This is an app for the Vision Pro. It allows you to see the Matrix, just like Neo in our film that we recently watched. So here we've got the Matrix. It looks very, very cool. But what's most impressive is that you can see the edge detection, right? And the wall detection is significantly better than, for instance, the HoloLens. It is pretty impressive. The edges, the exact kind of edges in the corner of the room are very mushy. You can see they're kind of rounded. Other than that, everything looks really good. You'll notice some of these walls move around slightly. They adjust. The vertices are adjusting as the player walks around. And that's very likely because as the headset gets more and more footage from different angles, especially from different positions, it's able to produce a higher quality, kind of more realistic mesh. And so this is why you see these little adjustments being made to vertices and the walls as you get closer and closer. So very, very impressive. And if the Vision Pro can get their price point down and get some people using it, the possibilities are pretty endless, it seems. So very impressive stuff. That's there have been things like this, but never to this quality. Never to this quality. and never kind of running this this effectively. So very impressive hardware. It's unclear if the latest, the current wave of VR is going to take over the world and change the way we live. Many of us change many of our ways that we live. But it is the kind of thing where we're going to have some really, really impressive hardware advancements as we're currently seeing it. And then if this current wave peters out, in a decade or two, we'll get the next wave, and it will be much stronger for the advancements made in this current wave. So if you're a little bit sad by Microsoft shutting down the mixed reality platform and sunsetting HoloLens, just keep in mind, probably more to come in the future, more and better. So what I want to do today, and we don't have a whole lot to cover. We covered a ton last time. But what I want to do today is I want to go through a few more of the tasks that we had, right? We've got this landmarks task, right? You are going to have to, in a very Pokemon Go fashion, you're going to have to basically plant some landmarks, some objects around your map. And when the player gets close to them and taps on them, they will need to learn some more things about those landmarks. And that's also how they unlock new types of seeds for planting. So what I want to do is I want to show you how to do that. I'm going to show you a little bit about the UI. In particular, we're going to create an inventory bar. So if you look at, let me see here. If you look at, I think we have a guide here that is going to, no, maybe it's here. Here we are. I didn't actually sleep last night. It's not something I'm proud of. It's simply something that happened. So there may be some yawns in this lecture. Let me see here. Okay, so if you look down here, you can see that we have these kind of horizontal bars that contain a bunch of items. If you look really closely, you can see that they contain a counter, right, telling you the number of that item that you have. It's an inventory bar, and it actually holds a lot of items. You can actually swipe to the right and find more and more items to explore and check out. Tapping on the button will either plant a tree, or if it's the acorn, it will shoot an acorn, which can be used to defend the tree against squirrels. And so, how do you build something like that? UI is pretty tricky in general, and it's something that we're going to go over. Okay. Okay. Let's go ahead and take a look at that. I just got an email on the scheduling of EECS 440 for next semester. Okay. So let's go ahead and let's go ahead and take a look. Let's do some landmarks. Okay. So a quick reminder on what we had last time. We have a avatar that can walk around, right? We have a cheat code with our arrow keys to kind of get us moving around a little bit, just so we can test some things. Now, when you build this to record your footage, when you deploy it to your phone, you'll actually be walking around, and it will be much smoother, and it will also go directly to your actual location. But we just have this cheat code in here for now. We got a camera that is following the player around. We can see that in our scene view. Right, where's our camera? There's our camera, right there. It's a little icon, right, looking downward, okay? And as we move around, the map actually kind of fills in around us, which is very nice. We also have a situation where we can click the switch mode button. This switch mode button will not disappear, right? It's part of a main canvas that has a button on it. This canvas will immediately, mark the game object, the canvas game object, with "Don't destroy on load." That means it's always going to be there. Okay. It has also been written to prevent other canvases from spawning in. If a second one does spawn in, it will immediately despawn itself, which you can see right here. We're using something called the singleton pattern in order to accomplish this. And so I think that's pretty good. We can switch back, and we don't have multiple canvases. It's just all good, all right? We also don't lose our place. I can move over to the diag, and we can switch modes and then switch back, and we'll still be right at the diag. Okay, so let's say that I'm looking around. Let's go map, Google Maps. Okay, let's say that I am kind of walking around, and I want to place, let's see here. I think this is Denison right here. Is that Denison? There was one of these I spent a lot of time in. Let's just try the diag. Okay, or actually let's try Shapiro. So we go to Shapiro and let's grab the latitude longitude. Now I would really love to have an object of some sort be at the Shapiro library so that when I walk over, I can actually go find it. I can walk over to it. When I get close enough to it, I can tap on it or click on it, and I will get some sort of blurb that shows up, and I unlock a new type of seed. You'll eventually have to do that. But how do I get an object to do this? How do I get a block, let's say, or maybe a model? Maybe you can download a model from Sketchfab. Well, I'm just going to worry about a block right now. Let's go get a cube. And let's see, where's that cube? Let's go ahead and take it to the origin really quickly. It's not super important where we put this for now. I'm just going to kind of move it over here. Let's make it a little bit wider so it's a bit easier to see. Right? It's about the same size now. It's on the same scale as our human. Maybe I'll make it a little bit bigger. Okay? I'm going to call this a landmark. And in Unreal, if you want to create multiple of something, you create a blueprint, right? And then you can take that blueprint and you can instance that blueprint, basically a class, in many different locations. Well, in Unity, you can do something similar, but it's called a prefab, okay? I'm going to take this landmark, and let's go ahead and create a folder called prefabs. I know I'm going to want there to be a lot of these landmarks. So I'm going to drag that landmark right in, and there it is. I can now drag as many landmarks out as I want. And if I alter the landmark, like I make it taller, all of them will change at the same time. This is the beauty of using classes, of using prefabs. You change the class, you change the prefab, and all the instances automatically get those changes. Okay, so we've got our landmark, but one interesting thing is that I know where it should be on the map, but I don't know where the landmark should be in the scene. Okay, I could try and move it around just so it's right, but this would assume that we're starting in the same location every time. Depending on where you are in our city, you might end up at a different location. So this isn't going to work. We need some way to anchor these landmark objects to a certain latitude and longitude, okay? Which means we should think about, and I just double-clicked that prefab. I'm going to go edit the prefab, double-click it. We should add a new component, and I want this component, let's say, lat longitude anchor, okay? So this is going to be a component that will anchor and make sure that the object stays at a certain latitude and longitude, okay? That's what I get for not sleeping. So let's say we want one landmark and we want this to kind of be at the diag, okay? So we've got this latitude longitude anchor, and we should ask ourselves, well, how do you figure out where we need to go? What x, y, and z position corresponds to a latitude longitude of 42.27, negative 83.73? Okay, that's going to be a bit tricky. Fortunately, fortunately, there's a utility function that we can use, okay? And this utility function is actually, it is on our map object, okay? It's inside of the abstract map component, which is a part of the map object, which is a child of the location-based game object. So that's a lot, right? We have to get this game object, and then we have to get this game object, and then we have to get this component. Once we've done that, mission accomplished, okay? So let's do it. Let's see if we can do it. Let's open up lat long anchor. Let's give our designers the ability to choose any latitude, longitude they want. I believe that was a vector 2D. Yep, vector 2D. Let's call this lat long. Okay. And let's see here. When we go to actually use this, we need to now get that reference to that abstract map component. So the first thing we should get is look through our hierarchy. We say, okay, there's the map and there's the component. So first we need to get the location-based game. I'm going to go ahead and do that. Let's go ahead and go gameObject.find. Okay, location-based game. Then I want to find another game object, a child game object. So I need to find the map game object with a capital M. Okay, so I've got this first game object, but I want to find the child. So can I do find, or let's go transform.find. Okay, there we go. And then we can provide the name of the map. Okay, and let's just get that map for now. What type are we getting here? A transform. Okay, let's go transform map T. Okay. This transform component is literally, let's see, this right here. This top component of map. Okay. Actually, wait a second. No, this transform is actually location-based games transform. So here you go. It's right here. Okay. Then we can do .find to get the map transform, which is this component, and then we can use get component to get that abstract map, okay, if it exists. So if map T is not equal to null, then let's go abstract map equals map T.get component. There we go. Okay. If map is not equal to null, so lots of null checks, right? We can search through our map to see if there are any good functions here. Now, I already told you there would be. If you look through here, I think there's something called a geo. Let's see here. I think there's something called geo to world. Let's go. Converts a latitude longitude coordinate into map space. And we have a vector 2D and we'll get a vector 3. Rock and roll. Okay. Very good. Latitude, longitude. Vector 3. Okay, vector 3. Let's call this scene position. Okay. Now that we have a scene position, we can just move ourselves there. So transform.position equals scene.position. Oops. There we go. A reminder, whenever we type transform, and this is within a component, this is a shorthand for going and saying get component transform, okay? It happens so often that we just have a shorthand for it. And this transform is going to be, let me see here, this transform right here, okay? So it's going to warp to the right position based on the latitude and longitude we give it. So let's give it one, okay? Latitude, longitude, X, Y. So let me see here. Is this going to be right? I have to experiment a bit. I'm pretty sure that's latitude. Let's go over here. Okay. Okay, and Y. Okay. All right. Let's see how it goes. If everything's working okay, we should see a big box on the diag. Okay, the big box has disappeared. It's going to do its job, hopefully. And let's get over there. Yep, it is right there on the Shapiro Undergraduate Library, which is exactly where we grabbed the latitude longitude coordinates for. So there we go, rock and roll. You can convert between scene positions and kind of latitude, longitude positions, map positions, using functions like this, okay? And I believe you can also go in the other direction as well, world to geo position. Anyway, the takeaway here is that in order for this to work, in order for us to do this calculation, this transition or conversion from latitude, longitude into world coordinates, we need to have a reference to the map to do that. In particular, we need the abstract map component, which is on a map game object, which is underneath. It's a child of the location-based game object. So anyway, that's what you can see happening here. We grab the location-based game object right there. We grab its transform right there. We use that transform to find children of the transform. So map right here. And then once we have the map and it's all good, it's not null, we can grab that abstract map component. And if that's not null, then we can do our calculations. Sounds like a lot of work, but not too bad, okay? And you'll get used to it. It'll go much faster. Okay, cool. So now you can kind of get started with landmarks. I encourage you to grab a different 3D model, one that looks a little bit cooler, a little bit more kind of with whatever theme you're thinking about doing. Remember, this can be themed in any way you want. The assignment spec has, I think, where was it? You saw the spaceman, right? The astronaut walking along the surface of the Earth. So you can be as creative as you want. Okay. So the next thing that I would like to do is I don't think we're going to do too many collisions this time. I think we'll save that for next week, maybe. A little bit deeper into Project 2. But what I want to do is I want to work on a little bit of UI, okay? And let me see if I have... do I have any seeds? Do I have any? Let me see here. Images, other resources, no. Mapbox, nah. Okay, let's see if I can find them. I think I usually keep them in course materials for 40, P2, seed icons. Let's go. Okay, we got some very cool seed icons in here, including the Shrek tree. And we just need to bring them in. So let's go ahead and do that. I'm going to drag this right in. Okay. Good, so we now have all the images we could need, so we need to get them now into the UI. So it's often useful to kind of zoom out a little bit so you can see the UI. Remember, UI, well, I guess if you can see the UI, UI is in a different kind of coordinate system than most of your normal scene objects. And so we have to be careful. Remember, there's this topic of anchoring, right? So we need to anchor our UI objects so that we know, well, hey, when you say x is equal to 5 and y is equal to 10, what is that relative to? Is that relative to the top left corner of the screen or the top right or the bottom? It's not obvious until you go set it, okay? I want to make sure that I'm recording and staying alive, just to make sure I don't lose a ton of work and have to go back. Let me see here. Boop. I'm checking on the Twitch app. Let me see here. Stream. Yeah, are we? Yeah, I think we're still good. Okay. So, what do we need to do? Well, we want to have the ability to kind of scroll our items here. And so, fortunately, Unity provides us with a really nice object called a scroll view, okay? Just do a quick check real quick. Click on Canvas and make sure you have scale with screen size in the Canvas scalar component and then a reasonable screen resolution. But then let's right-click on the Canvas game object. Let's go to UI. And let's go to scroll view, okay? The scroll view just kind of pops into the middle of the screen here, which isn't really where we want it. We can make it larger if we want to, and we will want to do that. We can kind of make it the size of our screen if we want. Actually, though, what I'm going to do is I'm going to say, hey, I want to anchor us to the bottom of the screen because that's where I want the origin of our coordinate system to be. But I don't want to just anchor it to the middle bottom of the screen. I actually want to stretch it along the bottom of that screen. So I can double click on that. And now when I zero all my things out, my coordinates out, I'll actually align perfectly to stretch to the horizontal width of the phone. Let's go Y. Okay, now we're down at the bottom. I'm going to lift that a tiny bit to get that in the screen. Cool, okay. So, one thing I'm not a huge fan of are these little white bars, but I think we'll take care of them a bit later. What we need to do is we need to add something to this scroll view. If you open it up, you'll see that's actually pretty complex. You can see a few game objects representing our horizontal and vertical bars. We'll come back to those and get rid of those soon. If you go to the viewport and content, anything that you put inside of this content game object is going to kind of be considered inside of the viewport. So let's go ahead and create some things. Let's go ahead and create an image. Okay? We create an image, and I can just kind of move it around. I can create more images, and nothing really happens. When you want to kind of lay out game objects underneath, another game object, right? When we want the children of content to be kind of laid out in a nice horizontal fashion, you actually need to use a component. Surprise, surprise. And you need a layout group, okay? In particular, we want a horizontal layout group. This component is going to take any child game object that we put in here, and it's going to kind of resize it and move it around. So let's go ahead and test that. Let's go to UI. Let's go to image, right? It's also going to affect the position. So I got one image, and it was forcibly moved over to that left side of the screen. So when I make a copy, right, it actually moved that one over and kind of used the space a bit more, okay? Which is kind of cool. For now, what I'd like to do is I'd like to focus on making this one image look good, okay? So, what can we do? Sometimes I forget exactly what I do in here, but I think we can probably make things a little bit wider. How big is the content view? 300? I don't think that's right, is it? Where is the content view? Canvas scroll view up here. That's fine. Oh, it's 200. Okay, 200. Okay, content should probably be 200 as well. And I'm going to take this image and I'm going to make it 200 by 200. Okay, we now have a really nice little square, and I'm actually going to drag some images over. I can't drag these yet because they're textures and I need them to be sprites. So I'm going to shift click all of them, go to sprite, and then go to apply. Now it should be possible to hook up these things into the sprite column, and there we go. We got our nice little magnolia button, okay? So this is a great start. I'm going to take this image, I'm going to rename it. Now we know we're going to need a bunch of buttons, a ton of them, okay? So I'm going to call this, let's call this inventory. Did I spell that right? Inventory button. And I'm going to go ahead and put this into my prefabs folder, okay? Now I'm going to make some copies, okay? As I make more and more copies, they kind of get spaced out in a really weird way that isn't very pleasant. So I think we can deal with this by going to our horizontal layout group and getting rid of child force expand. Let's see here. Yeah, there we go. Right, so now as I add more in, and even as I delete them, they all stay in this really nice little line that just kind of builds out to the east. And if it builds out a ton, what we need is the ability to kind of scroll and see them all, okay? So I've got a ton of these buttons now. You can see them. They're hidden off the right side of the screen. And I want to be able to grab this and kind of scroll bar and just kind of push it and slide it to the left so I can see the rest of these. However, I think we're going to run into a problem when we try and do that. So let's go ahead and run this. Okay. Cool. Now, okay, I can drag and try and pull them over, but then when I let go, I lose them. Okay, that's not good. Not good at all. So what's happening? Well, our problem is that we've got more of these inventory buttons than ever, but the content game object has not gotten any wider, right? It is only still filling this tiny part of the screen. So what we need to do is we need to use something called the content size fitter. And I think maybe I have to set horizontal fit, but this component is going to kind of expand, it's going to expand this content game object to fit all of its children, okay? So let's see if we can do that. Horizontal fit, minimum size, let's go, okay? That's looking pretty good. Hopefully this allows us to scroll over, see more of the buttons, okay? So I'm going to click and then drag, nice. And I can just kind of throw it to the side, and when I get all the way over there, it's stuck, but I can go back if I want to. Awesome. That was super cool. Now what I want to do is I actually want to get rid of these horizontal scroll bars. I don't think they look that great. You can keep them. We're not grading super harshly in this course on aesthetics. But I'd be pretty happy to get rid of them if I can. So there we go. They were deleted in a vertical scroll bar. It's a little bit weird. It's a little bit weird that I can't see anything right here. Isn't that strange? Why is this button getting cut off, I wonder? Right. Aha. Okay, so the right viewport is actually not stretching all the way to the end of the camera. It is falling 17 units short, so let's go 0, and now it looks good. It looks good to me. Okay. Okay, so let's go ahead and run our game. Yeah, there you go. Looks pretty good. Now, this isn't quite good enough for our buttons, right? Number one, these aren't buttons, not yet, okay? And so I think what I want to do, can I go in and add a button? Yes, I can. So I want to edit all of these buttons at the same time, okay? Which means I'm going to go to that inventory button prefab, and I'm going to double click it. And now what I want to do is I want to go in and add the button there. That should allow us to affect all of these at once. Now what I'm looking for in this test is I want to see that when I hover over, the color slightly changes, okay? Very slightly. And when I click, it gets darker significantly. So we know the buttons are detecting our mouse cursor, and they're responding to our actions, which is very cool. Okay, these buttons need to have some sort of integer, okay? They need to have some sort of number on them. If you recall from our design document, right, you are going to have all these different types of objects, acorns, seeds of various types, but you need a way to basically tell the user how many of them they have. One of the tasks on this project is going to be you building out a little mini store that you can bring up. See a little store icon, or shop button, and you're going to allow the user to buy more seeds or more acorns. And so we need some sort of number here on our buttons to indicate what's going on. By the way, eventually you'll also have to change the aesthetics here, right? So your first button might be magnolia, but your second one might be palm. Your third one might be pine. These are really beautiful photos. What about the Shrek tree? No, I don't want to use the Shrek tree yet. These look too nice. I don't want to ruin it. Let's go for the others real quick. Okay. All right. So we can go into that prefab for our seeds, our seed buttons. If we can find them. Yep, prefab inventory button. That's what we're looking for. Good. And I want to add in a number. So let's go ahead and go to right-click on the inventory button. Let's go to UI. I want like a default text, okay? I want a default text. You can see it right here. but it's kind of dark. It's not very big. It's kind of hard to see. I want this to be anchored at like the top center of our screen, okay, of our button. So I'm going to anchor it up there, the top center. I'm going to zero out our coordinates. Now it's hanging off of the button, so I'll pull it back down. I don't like it off to the left like this, so I'm going to align my text like so, and I'm going to also make the text bigger. So let's make it a little bit bigger, maybe bring it down a little bit more, okay? And we can just imagine a big 1 right here, right? You've got 1 button left, or 3 left maybe. It's a little bit hard to see this text, and it is kind of, it's very dependent on what the background is, what the background image is. So let's go ahead and do this by, fix this issue by adding an outline. So let's do a nice black outline. Okay. Let's change the color, something brighter. Okay. I want that bigger. I just want that bigger. Okay, we'll make it so. Okay. All right. And I think that's good. Maybe I'll make the outline a little bit more stark. And I'm going to call this text. Let's call this the count text. Okay. The count text is going to tell us how many of each item we have. And because we made this change on the prefab, now all of our buttons have it. All of our instances have it. And so that's great. A question is, well, I want to do something. I want to do something when the button gets clicked. How about? And depending on which button you click, you might want to do a different thing. And so what's a good way to attack that? So if this were a really big project with, dynamic buttons, hundreds of different seed types, what I would say is we should dynamically generate these buttons, put them into our little inventory here, and then we can kind of dynamically decide what happens when you press a particular button. However, what I would probably recommend doing, because the number of tree types you're going to have, the number of inventory items you'll have, is going to be very finite, and it's not going to expand too much during the project, I would probably, let's go to our little inventory button here, let's see. You know what I think we're going to do? I think instead what we're going to do is we're going to go to the canvas. We'll go back to the main canvas. We already have the script available to us. And we can write some code there to set some things up. Okay? Let's go ahead and let's write a new function, void. Let's call this establish inventory buttons. Okay? We're going to run this when we spawn that main canvas in. And one of our goals here is going to be to grab these buttons, and we want to set up a function that can get called when we need them to be called. So let's also do this. Let's go ahead and create. I'm going to actually put them down here. Okay, so they're closer to the function that sets them up. Let's go public. Let's go public button. Okay, and let's call this the Magnolia. Okay, Magnolia button. When we create this public variable of type button, it's going to create a variable down here, a little slot, where we can drag that button if we want to. So I'm going to grab that first button, bring it right in. There we go. So this is literally a reference to this button right here, which means we can change it if we want to. What I'm going to do, now is I'm going to go, hey, Magnolia button, I want to add an event to the on-click event, okay? Let's go, can I go add listener? Yes. And then I need to provide it with a function to run. So let's go, let's go click Magnolia. Okay, this is the function that's going to run when I tap that first Magnolia button. What do we want to do? Well, the first thing we should probably do is just make sure this is working the way we expect. Okay, so let's print a message. User clicked Magnolia. Okay. So we're going to go ahead and run this game. I'm going to be looking at the console to see if I can find that button. Okay, clear. And okay, so I'm going to clear out my messages and then ready, 3, 2, 1, click. User clicked Magnolia. There we go. Now, if I click the other buttons, I don't get anything. But if I click that first one, I get to run any code that I want, which is really cool. So let's just do it for one other, just to check out and make sure it's all working okay. What's that, Palm? Okay, so let's go on click Palm. Now I'm going to need another variable so I can hook things up. Let's go public button Palm button. Okay, and let's go Palm button to on click, add listener. Okay, on click Palm, boom, there we go. And we'll go ahead and put some more debugging code here. So on click Palm. Okay, we'll do a quick test here to make sure it works for both buttons now. And you can kind of see the process for how we're dealing with all of these buttons. And I'm going to hook them all up. So I've got Magnolia, boom, Magnolia message, and then I've got, oh, that one is not working. So let's look at the error message here. Hello, yeah, there we go. Yes, so 32. Okay, 32. What line is that? Okay, oh yes, I didn't drag it in. Yeah. Okay, so let's look at our main camera. Sorry, our canvas. Yep, so I forgot to drag in that Palm button. It's going to be the second one, right? That one. And so now let's go ahead and see if it works. Okay, click, click. There we go. User clicked Palm, user clicked Magnolia. Awesome, wonderful. Okay. So clear and yeah, looking good. So one thing you'll want to do with these buttons is, hey, you might want the number to go down. If you have some logic in here, some data that says, well, hey, how many Magnolia do you have? What you might want to do is you might want to change the text to say a different quantity. So when Magnolia is clicked, let's see if we can do something to change that text. We have the button, right? We have this button right here in our code. But what we really want to do is go into it, go grab its count text and change that number to something. So let's do it. Let's see if we can grab it. So let's go Magnolia button. How do we get something that is underneath another game object? Well, you go transform and then .find, okay? And then you provide the name. So count text. Okay, this is our game object, but I actually don't want to get the game object. I want to get the text on it. So text, let's call this count text, okay? And this is the game object we're getting right here, right? Or the transform, actually, but let's go ahead and get a component, and let's get that text component, okay? Just to be clear what we're doing here, count text is a game object. This count text game object has a text component, and that's what we're grabbing right here. Grab the game object, then get the component. Store it in this variable so we can edit it. Count text.text is equal to, I don't know, something crazy. Let's just do like an exclamation point, okay, and a question mark. Cool. That's our little test to see if it is all working. Okay, clear, and we'll go in, and let's see. Okay, so I'm going to go look here. I'm going to click on this, and then boom, it changes its text. Okay, so awesome, very good. So something that you might need to do is, when the game begins, perhaps down here, you might need to do something where, hey, maybe we're storing the number of seeds that we have. So static magnolia count equals 9. Now that sounds like way too many, but maybe that's what the current count is. So it's 9, and when we set up all these buttons, we also want to set up the text on the button. So we'll go count text dot text is equal to magnolia count dot toString. Okay. Down here, what we could do is we could say, hey, magnolia count has to go down. So minus equals 1, or just minus minus is fine. And then we're just going to run this code again to update the text, okay? So we'll go down and down and down. Perhaps we should only do any of this if magnolia count is larger than 0. If it's smaller than or equal to 0, then we should just do nothing in return, okay? So let's see how it goes. With this approach, you'll find that there might be a good chunk of copy-pasted code, and you can definitely get around that, and you can make that much more dry and less error-prone if you take more of kind of a database approach, where you've got this data saying, hey, you've got these buttons that exist. Each, this button has this image and this starting count. And you're just kind of dynamically creating the buttons in C# and putting them in there. However, you have a finite amount of time in this project, and this is not EECS 494. This is not EECS 498 game engine architecture. So I would not begrudge you taking it a bit easier. Anyway, I click on the magnolia. Awesome. Boop. I just planted a tree, maybe. If I was in interaction mode, we should plant the tree. Okay, 7, 6, 5, 4, 3, 2, 1, 0. And then if I keep clicking 0, I don't do anything, okay? At this point, I would need to go back into my little shop, and I would need to click some buttons there to exchange currency, my money, for more seeds, okay? And so, yeah, we got some good stuff going on here. We have a bunch of data that has been set inside of our main canvas, right? The main canvas is currently keeping track of, well, how many seeds do I have, right? One question you'll need to answer, is you'll have to answer, hey, when I plant a tree in interaction mode, how do I keep track of that? When I go to interaction mode, I decide, hey, I want to plant a tree here, okay? And I click on magnolia, boop, like that. I'm moving my mobile device around. I tap that magnolia button down there. I expend a seed. I plant a tree. How are we going to keep track of the fact that I just, planted a tree there? How are we going to keep track of how grown that tree is, what type of tree it is, where it was planted, okay? And what I recommend you do, I'm not going to do all of this for you, but what I'll recommend is a certain approach, okay? I think it would be wise if you created a game object just dedicated to managing all this. So I'm going to call this the tree manager, okay? Let's call this the tree manager. I'm going to create a component called tree manager. And this component is going to do the same thing that the canvas did, okay? I want this game object to just always exist, all right? I want it to always exist, so I'm going to use that singleton pattern, static tree manager instance. And let's go, hey, if instance is equal to null, then we're going to claim the instance. Instance equals this, okay? Else, oh, and I need to remember to mark as don't destroy on load as well, so that we don't get destroyed when we go to other scenes. But if the tree manager already exists, then I'm going to go ahead and destroy this game object, and then return, stop executing code, end the function, okay? Don't do anything else. So now, now what we should probably do is we should create some APIs to kind of let trees be made, okay? So let's say that I want to create a new kind of tree. So maybe I can go public static. That static means that I'm going to be able to kind of call that from anywhere. There's going to be one copy of this function. It's a class, well, it's a function associated with the overall tree manager class and not any instance of that class. So let's go public static create tree, okay? And you might say something like, oh, I don't know, what kind of tree do you want to create? So string tree type, and let's say that's good enough for now. Well, if I want to create a tree, I can call this function from somewhere else. If I want to, main canvas, right? Maybe when I click Magnolia, I'm going to let's go tree database, or let's go tree manager dot create tree, and I want to create a Magnolia, okay? Right, I can now call this function from my UI logic, but what does it mean to create a tree? What does that mean? Well, one idea you might have is, let's go ahead and say, hey, I want to have a class that represents a tree, okay? It represents a tree, and what information do we want on a tree? Well, we might want a tree type variable. We might want a size variable, so float size. And it starts at 0, but when it gets to 100, it's 100% grown, and it's all good, okay? We might want to track, hey, does the tree have a squirrel on it? Public bool has squirrel attack, okay? And that's going to start as false, okay? I'll make these public as well, so we can look them up later if we want to. Okay? If we have a tree like this, then what we can do is we can store it. We can create a new tree. Let's go ahead and create a new tree. Okay? We can say, hey, that new tree, okay, it's going to start at size 0. It has no squirrel tag, but we do need to set the tree type like that. Okay? Now, with the tree created, we have to have someplace to store it. So what if we created a data structure, okay? What if created a data structure like, I don't know, a list? This is basically an array or a vector, an std vector of type tree. Okay, this is going to store all of our trees. We can call it all trees. Okay. And so when we call this function from our UI button logic, right over here, if you've forgotten it, right here, boop, we're going to create a new tree object, change its type to what we want it to be, and then we're going to go ahead and add that into our tree array, our tree list, as it's called in C#. Right? Now, if we ever want to know about all the trees that exist, we can always get that information by returning a reference to that list. So let's go, we're going to have a function that gets us a list of trees. Let's call this get all trees, okay? And we're just going to return all trees, okay? Because this is public static, we can now call this from anywhere. So if our main canvas needs to do something with trees for whatever reason, I don't know, maybe it wants to just anchor them or show them or whatever, maybe we're returning to the exploration scene, so we need to spawn in some objects to show the trees, right? What we can do is we can get that list of all trees. We can get it from tree manager.getAllTrees, okay? Now we got that list. We can iterate through it if we want to, right? For each tree and all trees. And we can, print out the type of trees that we have. We can go and place landmarks at the tree locations. Oh, that reminds me. Another thing you probably want to remember for your trees is the latitude, longitude. Okay, so vector 2D. Okay, can I do that? Vector 2D. Bingo. Okay, lat long coordinate. Up here, do you remember how we can get the latitude and longitude? Whenever we go into interaction mode, and we think about creating a new tree, we can get the current position of the player. Let's see, latitude, longitude. We can get that by going to that crazy class, the super long name, and grabbing that player lat long value. So doing this, and then we can go player lat long, and boom. Now, whenever we create a tree, we'll also store where the player is standing in the world. And that will allow us to kind of keep track of where the tree was placed. And because it's in the object, and the object is in this all trees array, we can now look that up anytime we want. So we could, for instance, spawn in some landmarks to represent the tree and give it those coordinates. Okay, use it with our anchor, our lat long anchor, and it's all good. Okay. One interesting thing is that these trees need to actually change over time. So we've got all these tree objects, right? We got all these tree objects, but over time, we want to update them. We want them to grow. So you might have an update function in this tree manager that, goes through each tree, and it might say, hey, tree, you need to increase your size by a certain amount, tiny amount, right? And hey, if that tree is fully grown, maybe we need to give the player a little bit of cash. I think that's actually a requirement. You need to increase the player's currency if the tree is fully grown, and if the tree does not have a squirrel attack. Okay, so you might say, hey, if the squirrel has a squirrel attack, if that's false, so there's no squirrel attacking the tree, then we can make the tree grow. And if the tree is fully grown, okay, 100.0, if the tree is fully grown, 100%, right, then you can increase player currency by some amount, okay? Maybe that amount depends on what type of tree you've got. Anyway, you can see here how we've basically, right, we've created a bunch of UI. We have programmatically hooked that UI up so that it does certain things. We can do different things when that UI gets clicked, right? Like in here or in here, right? So clicking on the palm actually won't create a tree, but clicking on the magnolia button will currently. And we create a tree object. This is just a normal C# class. We put that new object into our all trees array. At that point, we can do anything we want with those trees. We can look up and read those trees and do things with them from anywhere in our entire code base just by calling tree manager dot get all trees. And we can also have the tree manager automatically update our trees and make them grow. Maybe we can have the tree manager put a squirrel on the tree if necessary, right? If it gets unlucky. So we got a pretty good solution now that you can extend for ferrying this tree-related data kind of across the way, right? So it doesn't matter if we're in interaction mode or exploration mode, this data is still there. Now, one big, tricky thing for you is that you're going to have to make sure that the trees are represented properly. So you might have to actually, when you go back to exploration mode, you might have to spawn in or create dynamically a little tree model, a little tree game object, and then tell it, anchor it with that latitude, longitude anchor it to the right place, give it the right size so that it looks up how big the tree is currently, so we can watch that icon get bigger over time. If there's a squirrel at the tree, it should be visible. So even in the map view, the exploration mode, the exploration scene, if there's a squirrel there at that tree, then we should see a little tree or squirrel icon or a squirrel model nearby. So anyway, right, this is the kind of stuff you'll have to manage, and it's going to get a lot easier if you understand what we're doing here, okay, and how we're doing it. So if you have any questions about any of this stuff, please ask us. Come to office hours, and we'd be happy to kind of explain what's going on. It'll make this way easier, okay? I think, content size fitter, layout element, this all looks pretty darn good, okay? static, right? Using that to keep data around. Good. So I think actually we might just stop here. Okay, a little bit early. We've covered a lot of ground. You don't need to do much more than this for your deliverable. Okay, and so I think we're going to peace out. You will eventually need to add some custom stuff. You'll need to do some music. Okay, that's not too hard. And you will need to get some basic seed usage and some basic tree placement going on in interaction mode. That might be the hardest task after this, just spawning in the tree, right? Making sure the trees appear in the exploration mode. But remember, you don't have to have all of every task done, okay? But we do want you to seriously start all of these tasks. All of the white ones and the red ones are going to be for P1 Alpha, which will begin, I think, on Monday, right? Yeah. Oh, no, actually, it's going to begin, P2 Alpha is going to begin on Wednesday, okay? And we're going to help you and walk you through some more of those P2 Alpha tasks and how to attack them and how to think about them during this next week. Well, not next week, but the week after that, okay? All right. Does anyone on Twitch have any questions? I think there are a number of you watching, though you've been a little bit quiet. That's totally okay. No worries. Otherwise, I hope you all have a phenomenal break. You're working hard, and you're doing good work. So I hope you will also take a very meaningful rest. Okay. Hopefully you can. I don't know what your other courses are up to, but do the best you can. Okay. I think that's just about it, everyone. We're going to cover some of these other topics on a future lecture, and we will see you then. All right? Take care. Bye-bye.